Hello everyone, my name is Dinesh. I, along with my other three teammates, Malinda, Abhay and Puneet, have been working on this really cool project. This project is a part of our software design coursework, and the project is given to us by Rockwell Collins. The project's idea is all about a Linux file synchronization daemon or application. The idea is to synchronize specific home directories on computers on a network. So what I'm trying to do is I'm trying to show you guys a small demo. I have two computers hosted in Linux Lab 254 in IAC, and I'll be using PuTTY to connect to those two computers. The first computer or the first node is 134.129.106.247. This is the IP address of the first node. The second node's IP address is 134.129.106.244. And I'll be using WinSCP to connect to these nodes to show you the whole synchronization process. Trust me, it will be much easier to understand with, using WinSCP. So let's start it. Let's connect to the first node, and I'll just put in my username and password. And let's connect to the second node too. Okay, so I've connected to the two Linux machines, and on these two Linux machines, this is the folder which is being watched for any file changes. That means this folder, home user test1. On node 22, the same folder, home user test1. So let's try to run the application on node 1. Test31 is our executable application. Let's run that. It's developed in C++. Okay, so on node 1 the application has started. So let's start the application on node 2 as well. Okay, on both the nodes the application has been started. Now, as I've told you guys, on these two nodes, this is the folder which is being watched, home user test1, home user test1. When I say that this folder is being watched, that means if I make or create any files, or if I change any files in this folder, all of those changes will be synchronized to other nodes in the network. So let's try to create a file in node 1. Let's just rename it or name it ABC, and save it with some data like nd-srocks, and let's just save it. As soon as I save this file, as you might just have seen that there was some activity between these two nodes. So as I've saved this file on node 1, by this time now the same file has should be synced on the second node too. So let's just refresh it, and there you go. So the same file ABC which I created in node 1 has been synced to node 2 and the srocks. So let's try to do it other way around. I'll be trying to create a file in node 2. It should be patched in node 1. As you can see, this activity. Well, this activity is nothing, but this activity is because of a subsystem. It's a part of Linux kernel, which is iNotify subsystem. What it does is it keeps a watch on a specified directory. We have to specify a directory which we need to keep a watch on. So right now in the application we have specified this path. That means home user test1, home user test1. Any file changes made in these directories will be captured by iNotify system, which then again creates an event and send the event to the sync application, which does the sync. So as I've created this file on node 2 czszczs, and this file has been synced to node 1. Let's just refresh the page, and yes, the file is here now. So well, this is the two-way synchronization. We tried to create a file in node 1, then the file was synced in node 2, and then in node 2 the file was synced in node 1. Now what I'm trying to do is I'm trying to edit the file. So let's try to edit the file in node 1. Let's write ndsu is in Fargo and just save the file. The file is being synced right now and is probably synced right now. So what I want to show you guys is this application is efficient too. That means it doesn't hog the bandwidth. Only the changes are synced now. So previously this was the text entered. This time I entered ndsu is in Fargo. So the whole file is not synced to the second node. Only this text, only this change is synced to the other node. This is possible because of the algorithm, which is our sync algorithm, which creates a difference between the two files, one in node 1 and in node 2, and the difference, which is we can call it delta. Only the delta is patched to the remote file in the remote machine. So this is efficient too. This application can handle any number of nodes. Because right now I'm connected to these two nodes in IAC lab 254 using putty. It's quite hard. It's quite complex to understand if I put 4 nodes here, and that's why I've just shown you guys a demo using 2 nodes. But this application can accept any kind of nodes. All we need to do is put the IP address and path, which we need to sync in the configuration file, and then it will handle any kind of synchronization. So this is all about the project we have, and this is a really cool project we have worked on, and personally I would say this is the most challenging project I've ever worked during my academic career, and I think that's pretty much about it, and I hope you guys have liked the video. Have a nice day. Thanks.